Welcome to Accelerated Learning. This is data structures in Java. So I already coded this. Um, what I created was a static or fixed array. Um, Java already has like arrays. You have to declare them as a certain type. So what's good about this is building your own data structure or designing your own data structure is you can create a structure that does what you want rather than having to use the built-in. It's good practice if you're learning a new language. It's good practice. Um, so this is the code. Let me explain a little bit more about why do you need an array? Why design your own array? Well, there's this fixed array stores any type of element or object. This provides greater flexibility because Java arrays are type specific. I include error handling, so it makes it safer to use and it reduces the risk of runtime errors. The fixed array encapsulates the array data, provides control access through getter and setter methods, and it promotes good object-oriented programming. It's like I said, it's custom. It does what I want, and it provides whatever you need, depending on how you design it. And also, it's a clear and structured way to work with the array, so it makes it kind of more readable. Um, so let's go over this code. So it's a public class. It's accessible and visible for all the rest of my classes. So the private variables are only modified by this class, and the object is the root of all classes, and this stores any type of element. So I'll be able to create an array with integers and strings and doubles, like floats, like 1.1 and 1 in the same array. And this is the constructor. So to create a fixed array object, all you need is the size. So I made sure that it has to be at least 1. There's my getter method. It returns the index of the fixed array, what the value. So the index is like the key, and the value gets returned, and you can set value at an index in the fixed array. And also you can get the length. This returns the length of the fixed array. That's how those are public. So these are going to be accessed with my other from other classes and other functions. This overrides the toString method of the object class. This is going to it's a usable, human readable form to write what's in the array in string form. So then let's just do I have an exception class and another file right there. So I can customize any type of this clearly indicates issues in the fixed array, and it's good for debugging to have this. It allows for the customized exception handling. It's not so generic. Sometimes exception handling has real generic messages that are hard to to figure out and stuff. So all right, so I created some functions to test my array, to and to debug my array. So So let me go over that. You can do all kinds. You can basically the fixed array. You can build it to do anything, and more. Like I said, it's already any type. Um, so like in Python, you have a tuple. So if you want to get a maximum and minimum of an array, you can return a tuple of a maximum and min. I mean, also you could even if it doesn't in Java, you can just get the maximum out of an array. Um, but I could have called this tuple, but this is I don't know. I wanted to make it more just group similar objects. This class it returns this object pair, and I'll go over the pair class in a second. Um, this function is the min max function. It returns two objects like a tuple, but Java doesn't have tuples. And I initialize the minimum and maximum, and it just is only. So this will actually iterate over the strings and everything, and it's just going to compare it's going to compare the minimum and maximum of the numbers that are in the array. So it's going to ignore all the strings, and it returns the pair. And let's go over the pair class. So generic, like I said, it's generic, and it declares two type parameters. I mean, I call them key and value, but I mean, in reality, like if I had made this just for min and max, I would call it min and max. And the constructor is just gonna turn when it's created, it's gonna have show key and value. It has setters and getters, and you return them. And so in this situation, it's going to return a min and a max, and also have the string to write them out. Okay, so I don't know. I was playing around with this. I originally do this in PowerShell. So so like you want to compile, and so I have this in a pack in the package data structures up here, and I'm just doing all of them, compiling everything, and then compiling the to that my test. And before, and it's the same code. The Linux command line. It's the same code to compile. I was just kind of using both. Anyways, let's see how I test the min max. So I just create an array. You can see I have strings and values and everything, different values, different types, a Boolean. And then I do one where it's all Boolean and string, no numbers, and it should return because I initialized it to null. The minimum and maximum should just return null. You see that type is pair. The class was pair, and you can see there. So, anyways, so I'm in PowerShell. I can do, like I said, it's the same for. I've already compiled this and everything, but I'll go over it again. It compiles everything in the package data structure. You got to make sure you're in the right folder. Compiled, like I said, I already compiled it. I haven't made any changes. And then I just run. the main program. This is going to run everything. But we'll go to the top, and there it is. There's the array that I created, strings and numbers and Boolean. There's the minimum and maximum. I just ignored all the rest of it. And then here's this one where it just has Boolean and strings, and the max and min are null. Okay, so let me see another function. It just reverses the array. So the array is returned if there's no length. Of course, it already error checks. If it is length 0, it's gonna throw an exception, like I set in the fixed array. So no, but normally if the length is 0 and length is 1, you just return the array. This is like reversing an array is like a standard thing you can do. You create like a start, which is the length of which is the index, really, and you're starting at the last index, and you're just going to I create a fixed array object that's reversed, and it's just going to go backwards over the original array, and it's going to set. It's going to use the setter method of my fixed array class. And that's why it's good to have public static to have public static in particular, not, and don't let it be non-static, because I can call, I could create an object and just call it with that object from that class. Whereas if I didn't make it static, I would have to have like fixed array function. I'd have to always call the class. I'd have to create an instance of the class. So declare these. I didn't put these static. So you always have to, when you create an object, you have to create an instance of the class, you have to say fixed array and use the object to call these setters. So I left static out. So you always, that's why static is not there, is so because you create an instance of the class to use to access these public functions, getters and setters. Okay, so there it is. And you can see I called a length. When I create the object of that instance of the class, I can access the length function in that class, the setter and getter. So that's it. And so I already ran the code. I guess I can do it in subset system for Linux too. So I show you the code. So compile, kind of do the same stuff. And then so let's go to the reversed. See how you can see I updated and upgraded the WSL. So here's how reverse worked. It started with this. Had no numbers and just had booleans and strings, and just reverses it. And here's a number. I see it just reversed the first one. That's how that works now. Okay, so now value. So it has to be numbers. Like a median is like, see, you have 1 through 100 exactly. The median is like 50, or and then you got, so basically the trick with median is you have to make sure they're all numbered, because this is a generic type, an object. This is any type can be inside that array. So you want the median value, and it needs to be a number. That's usually what you use with median. You find the middle value of all the numbers of all the values. And so I check for number. If there's not a number, I throws an instant. throws a exception. And then I used a quick sort array in Java. Now later on, I use a linear array. This has a quadratic time complexity, so it's kind of slow, but when I was building this, I wasn't thinking about that. I just wanted to concentrate on median. But the idea of median is, and let's see here. And also I convert all numbers to doubles, so we don't get because later on when you divide, so to get the median, you divide the length by 2, and like that's why you need to convert everything to a double up here so you don't get truncated values. Just make sure everything's a double. I mean, a lot of times in languages, as soon as you divide by a double, or it's just good to start converting everything to double, because you know you're going to have to take an average if the length is even, and if it's not, you just get the middle number, you get the value at that middle index. Now let's go to quick sort. I wrote that in Java, public class quick sort. So this is the method to partition the array. And down here, I got the method to implement quick sort. This sorts the array and returns the sorted array. Also, I verify in here, just like if I'm using, so I created a class so I can use it with other functions, and maybe another function is not going to check the raw numbers. And so recursive, as you can see, it's recursive, and it returns the sorted array. So that's quadratic time complexity. That's very, if you have like a million, if you have a lot of elements to sort, see if so, and then so I just printed out the median of the first number and the second number, and I use these. I use this array right here, the second one, the reversed one. See right here, I reversed it. Result 3, I called that a fixed array, and then I just I did both of them. So the first one is this one, 1 to 10. That just finds 5.5 because it's even. And then what I did was I took out set initialize index 0 for result 3, which was in reverse. So I put this 10 as a 0. And that actually my intention was to eliminate one of the indexes. I just set it to 0, the value. So that still put it in the middle. But then you average the middle, you average now, you average the middle, and it becomes 4.5. Okay, and the next one is rotate left to right. So let's look at that one. It rotates the array now left to right. You're just basically have a fixed array, and if the steps are positive, you're going to rotate everything to the right. And if steps is negative, you rotate it to the left. This is also good to try not to use try to limit some of the built-in functions. And floor mod is what? step size is what Java has, but I just went and did it by hand. You basically you modulo the steps, you find the actual steps because someone says if the array is 100, size 100 elements, and someone enters enters the steps of 1,000 or something. You're doing the modulo. You normalize it so you don't have to do unnecessary calculations, and then basically this is a kind of a quick way. If it's a negative actual steps, if they give a negative number, you're just adding, you get that actual steps plus the size, and that will rotate it to the left. um, so you create a fixed array, rotated data, create the instance of the class, and then you just set the return the, you set it, use the setter. So down here, rotated right, it's the original array, rotated right here. See, it starts at 0, now it's rotated right, so now it's rotated right by 2, and when you rotate it left by 3, same array. Let's go to the main. See, this rotated steps are 2, and then when you rotate it left 3, it ends up being the same as those two end up being the same arrays. Now I did a little linear sort because it's so the linear sort is an n plus x time complexity. That's the number of elements in the fixed array plus the range of input values. So what you do is you count each value. You basically find the max and min. You use the function that I wrote before, the min max, to return a pair. And you find a range of the max and min. That's this is going to hold the counter frequency. See, max minus min plus 1. That's going to be the entire. That's all you need to do. Is that's all the values are within that range. So that's and now you have like a count, like array where you're going to count. Okay, and so array, I error check here if it's no number, if there's any booleans or strings, then I could convert any number to an element. I mean, to an integer. So, and so I use the setters and I getters to count each value. So there's multiple values, and then I create the sorted array right here, and I get I use the setters and getters. And I return the sorted array in non-ascending order. So that's that's a linear time complexity, which is a lot faster than quicksort. I mean, it'll show up. You can. I thought about putting a timer, but maybe I'll do that here. But so I just created some random in main. I created a random array with the fixed array. I use random numbers. So I import random there. So I create the array random, and then you can see that it's descending. So it's sorted linearly, and it's there's the original, there's descending. So that's a quick little fixed array data structure.